Oil, otherwise known as petroleum or crude, is a thick black liquid composed primarily of hydrogen and carbon. The physical properties of oil, such as its thickness, vary greatly depending on the specific combination of hydrocarbon molecules. Oil also contains trace elements of sulfur, nitrogen, and oxygen. Today's oil deposits were formed millions of years ago when dead marine organisms sunk to the bottom of the ocean bed and were buried under deposits of sedimentary rock. After subjection to intense heat and pressure, these organisms underwent a transformation process by which they were converted to oil over millions of years. This is why you may have heard oil referred to as a fossil fuel. Oil is found in underground geological formations called reservoirs. The rocks found in a reservoir have various physical properties that allow them to hold hydrocarbon reserves. Through exploration activities such as seismic, surveying, rock core sampling, and other advanced technologies, geologists locate oil reserves. Oil is extracted from the reservoir most commonly by drilling a well. Once recovered, oil is transported by pipeline, ship, rail, or truck to a refinery where it undergoes a complex refining process that creates petroleum products like gasoline, diesel, jet fuel, asphalt, and many more. Currently, the world uses oil primarily to power its transportation system and to create commonly used synthetic products like plastics and petrochemicals. The production and use of oil presents social and environmental challenges. Producing oil causes land disturbance, sometimes in environmentally sensitive areas. Oil-powered transportation systems contribute to global greenhouse gas emission levels. And control of oil resources is a persistent factor in geopolitical tensions globally.
Oil pollution in the oceans can have a disastrous effect on marine life. It often takes a major incident at sea, like a tanker spill or oil rig explosion, for most people to grasp the extent of the problem. Oil slicks can drift towards coastlines, killing seabirds and marine mammals, but these types of spills account for just 10% of global marine oil pollution. Most is produced by everyday maritime traffic, including illegal dumping and tank cleaning or onshore industrial activities. The ecological impact differs according to the location. Deep sea spills tend to be relatively limited and they clear up easier. As the oil becomes denser, it sinks, is broken down and destroyed by bacteria. Oil slicks on a rocky coastline or exposed beach can have a significant impact on marine ecosystems and take up to a year to be cleared away by wave action. Coral reefs are highly sensitive to oil pollution. Damage is often irreversible and coral regeneration can take up to 10 years. And pollution in mangroves or on sandbanks can cause very serious damage, lasting more than 20 years.
When oil enters the sea, many physical, chemical and biological processes act on the oil. Many changes happen at once. The slick moves and spreads and environmental processes alter its character. Some of the processes are most important immediately after the spill and other processes become increasingly important as time goes on. Spreading. Oil is lighter than water, so it floats on the surface as a slick. The slick, or spill, spreads over the surface of the water due to the force of gravity. Spreading decreases steadily as time passes. Dissolution occurs when the water-soluble components of oil break down into the large volume of water surrounding the spill. Only a very small percentage of oil dissolves. Sedimentation. The force of gravity will cause some of the oil to travel through the water and settle on the bottom. Movement. An oil spill will move in the same direction and at a similar speed as the water. It is moved by currents, tide and wind. Biodegradation. Many species of marine microorganisms or bacteria, fungi and yeasts feed on the compounds that make up oil. Hydrocarbons, oil, consumed by these microorganisms can be partially metabolized or completely metabolized to carbon dioxide and water. The rate of biodegradation depends on the temperature of the oil and water mixture. Evaporation causes some of the oil to transfer to the atmosphere. Lighter hydrocarbons evaporate more rapidly than heavy component. Weathering is a progressive series of changes in oil characteristics caused by physical, chemical and biological processes. The rate of weathering is highly dependent on the type of oil spilled. The lighter it is, the faster it is likely to weather. Dispersion. The spilled oil is spread into the upper layers of the water column by natural wave action. Oxidation. The chemical combination of hydrocarbons with oxygen is known as oxidation. Oxidation is slow compared with other weathering processes. Emulsification is the combination of two liquids, one suspended in the other. In the case of oil, the emulsion can be either oil in water or water in oil. Milk is an oil in water emulsion. Butter is a water in oil emulsion. Both types of emulsification require wave action and occur only for specific oil compositions. Water in oil emulsions are extremely stable and may persist for months or years after a spill. Water in oil emulsions containing 50 to 80% water are most common, and have a reddish-brown color and grease-like consistency. They are sometimes called chocolate mousse because of their pudding-like appearance.
Booms are just temporary floating barriers composed of plastic and fabric, designed to prevent oil spills from washing up on beaches and marshes, and to concentrate the spill enough so it can be skimmed or vacuumed from the surface by large skimmers. So how is it that we're one of the most technologically advanced countries in the world and we haven't figured out a good way to clean up our messes? The booms being used are borderline useless, chemical dispersants can be more lethal to the environment than the oil itself, and skimmers really only gather surface oil, not the heavier oil that resides in deeper waters. Across the globe, there have been 13 large-scale oil spills over the last 37 years. Two of the most recent, the Deepwater Horizon BP oil spill and the Exxon Valdez spill, have been classified as two of the world's largest man-made disasters, and even now, years later, continue to have detrimental effects on the wildlife and ecosystems that surround them.
A massive oil slick now covering some 600 square miles of the Gulf of Mexico, and it could start reaching the United States coast within hours.
the BP oil spill dumped 210 million gallons of oil into the Gulf of Mexico. The spill affected a total area of about 78,000 square miles, a space that could fit the entire city of LA 167 times. Of that 210 million, only approximately 6 million gallons of oil were actually removed from the water. In spite of the help of countless experts, scientists, and engineers, the cleanup effort fell devastatingly short. The only newer technique that was used during the BP cleanup effort was this super toxic dispersant called Corexit. When Corexit was combined with oil, the mixture became 52 times as toxic as the oil itself.
According to the charts, this is the best plan of action.
Yeah, great. Don't worry about it. It's a small spill on a very large table.
Sir, I think we are underestimating just how much coffee was spilled.
Yeah, that's a lot of coffee.
Well, we better hurry up because it's almost reached my laptop.
Calm down, calm down. Boom.
It's also going to destroy all the fish.
Oh boy. Okay. Boom. Look at that.
My God, it's encroaching on my map of Louisiana.
Okay.
Okay.
Okay. Look. Oh no. Fish.
Laptop.
Okay.
Map.
Okay. I'm sorry. Look. Oh no. Fish.
Laptop.
Okay.
Wait. I've got a brilliant idea.
Oh. Okay. Jones, you gotta hurry up. I think the public is getting suspicious.
All set. Damn. Didn't work.
Oh my God, we are really screwed now.
Look, garbage will fall into the coffee cups, stopping further spillage.
Now there's just coffee and garbage.
Wait, I've got an idea. Damn, I really thought that would work.
Well, maybe it doesn't work right away. Let's observe it for 3 hours and then reassess it.
Okay. We just wasted 3 hours.
Damn it. That's everything I've got.
God.
The gentleman from Halliburton are here?
Send him in.
Gentlemen, oh my God! You guys are partly responsible for this. You provided these styrofoam cups knowing they were unstable.
Oh, no. Don't put this on us. You know what? Halliburton doesn't have to listen to this. We are out of here.
I've got Kevin Costner on the phone. He'll know what to do for sure.
How big is the spill?
Pretty major, Mr. Costner.
Do you have a golf ball?
I have a ping pong ball.
Good, now throw it at the spill. What happened?
Nothing.